Okay, let's wrap this up with two more examples of integration by parts, and we will be done. Now, I believe the one on your homework has a 3 right here. So I'm going to go ahead and do this problem with putting in a 3 right here. And at first when I did this, I thought it was x cubed, but it's actually the third root of all of this stuff. So don't make that mistake, because it's a lot longer problem if it's x cubed as opposed to the third root. Basically, the only difference is this will have a power of a third versus a power of a half. And that's basically the only difference. All right, we need to pick u. And so u, in this case, is best if it equals x. We then need to pick dv. And in this case, dv is best if it equals x plus 18 to the 1/3 power. And again, if that was a square root, it would just be, whoops, sorry, I lost my focus. Again, if that was a square root, it would be a half instead of a third. Okay? Let's see if I can get my focus back. There we go. So the only difference if it had been a square root is be a half instead of a third. All right, so that means du is equal to 1 dx, or I'm just going to write du equals dx. So du equals 1 dx. And if we take the integral of this thing right here, dx plus 18 to the 1/3, that's going to be, watch this, 3/4 x plus 18 to the 4/3. All right, see why that is. If I take the derivative of this, the 4/3 comes down, which cancels the 3/4, and then we subtract 1 from this, so minus 3/3, which makes it 1/3. All right, so that's where this fraction came from. The 4/3 would come down, cancel, cancel, become 1/3. Also notice that we only have x plus 18 in here, so there's no chain rule or u sub we need to worry about. If there was a 10 in front of the x, then this would be another step with a u substitution. But luckily, we don't need to worry about that. All right, it is uv minus the integral of v du, and over here we have u dv. All right, so here we go. The only part we really need to worry about is this part on the right. So it's u, which was x, and v, which is 3/4 x plus 18 to the 4/3 minus, so that's uv, and our hope is that this integral is a little simpler. So v du is going to be 3/4 times x plus 18 to the 4/3. And then du equals dx, and so that's beautiful. It's just times 1 right there, and so we can just put it in. And this is an integral we are going to be able to solve in a similar way to how we did this one right here. So let's do that. This will be 3x over 4 times x plus 18 to the 4/3 power. Now I take the integral of this thing, so I jack this up by 3, so that'll be 7/3 is what this will need to be, and so that means this will need a 3/7 out in front to cancel. Okay, so let me walk you through what I just did. I knew that we're taking an integral, so the power will go up by 1, so it goes up by 3/3. That means that this is 7/3, which means we would need a 3/7 out in front to cancel. Watch if we take the derivative of this. If we take the derivative, the 7/3 comes down, which cancels the 3/7. Then this goes down by 1, so it goes 6, 5, 4, 4/3, and we get what we had right here. And I promise you will get better at that with just a little bit of practice. 3x over 4x plus 18 to the 4/3 minus 9/28 times x plus 18 to the 7/3 plus c, and we can just leave it just like that. Okay, awesome. Let's knock out this last one. This last one might be a little tricky. Let's find out. X squared e to the 2x, it is absolutely the case that we should let u equal x squared here, because that will get simpler when we take the derivative. In fact, du is equal to 2x dx. So there's our u taken care of. Then that means that dv is going to equal e to the 2x. dv is e to the 2x. we take the integral of that, so v will equal e to the 2x over 2. All right, and so hopefully that's pretty straightforward for you by now after a couple examples. Let's do it. It's uv, so x squared uv, x squared e to the 2x over 2. That's my uv. In fact, let me write it over here again. uv minus the integral of v du is what we care about. So there's uv right there, minus the integral of v du, which is going to be e to the 2x over 2 times 2x dx. Okay? So that's uv minus v du. So hopefully all of that's making sense. Oh, that's nice. Our 2's cancel. That's helpful. But we've got a little bit of a problem here. The problem is that we can't take the integral of this. And you can't even do a u substitution. Go ahead and try if you want, but the trouble is if you let u equal 2x, du will equal 2, which won't cancel this x over here. So guess what we can do, though? We can do integration by parts again. Yay! You know, I once did a problem where I had to do integration by parts 4 times. It was really exciting. It was really fun. So what we need to do, notice by the way that when we do this, this minus sign is going to be around a lot of stuff. So uv minus v du, all of that's going to be around behind this minus sign, so we're going to need to put all of that in parentheses. So let's do u sub again. This time we're going to let u equal x. That means that du equals 1 dx, like before, or just du equals dx if you want. Okay. Now let's do dv. dv equals e to the 2x, which means that v is equal to e to the 2x over 2, just like last time. All right? Okay, so we are ready to go. We still have this term out in front. And now this integral right here, we're going to do the uv minus v du on. So I'm going to put a minus sign and then a big old parenthesis. So we got uv. So this will be x e to the 2x over 2, which is uv, minus the integral, because we still have an integral, of v du, which will be e to the 2x over 2 is v, and then du is just dx. All right, so that's what we've got now. However, I have a really good feeling about this integral right here. And the reason I have a really good feeling about it is that we can take it. So this is going to be x squared e to the 2x over 2 minus x e to the 2x over 2. So notice that those do not cancel, unfortunately. Plus, because we have a minus minus, and that's maybe the most common mistake. That's why I really stressed putting all of this in parentheses. That's probably the most common mistake, so be careful there. The integral of e to the 2x over 2 is going to be e to the 2x over 4, because remember another 2 would kick out because of the chain rule. So watch, if you take the derivative of this, the 2 comes out, 2 cancels with 4, becomes a 2. Plus c, and we are done. So that is a very, very tough problem, in my opinion too tough for Survey of Calculus. However, you can do it. Just follow the steps that I just went through, and hopefully you can arrive at the correct answer. Good job on making it to the end of Chapter 4. I hope you're enjoying this a little bit at least. If I can be of any assistance, please email me. I'm happy to answer all your questions. And good luck on the Chapter 4 test, and I will see you in Chapter 5. Have a wonderful day.